Today we're going to try to solve this variant Sudoku, which was recently featured on Cracking the Cryptic. So, let's get going. Alright, this variant features killer cages. In a killer cage, we are given the sum of the digits in that cage. And that's it. I see a lot of cages summing up to 9. A cage summing to 9 can be done in 3 different ways, using either 1, 2, and 6, 1, 3, and 5, or 2, 3, and 4. So I'm looking at the second column and the 8th column, which have a lot of 9 sum cages in them. Similarly, the 5th row and 5th column are interesting because it's impossible for these two, for example, to be the same collection of digits, because then you'd have 3 digits in 4 cells. So these 3 are all different types. Why don't I use colors? I don't like these colors. There we go. This is red, this is green, this is blue. I have a top-bottom symmetry issue, which I guess is resolved by this 14 versus 15. Let's just make a guess for now and think about the consequences of that later. Then this is red, this is blue, this is... no, excuse me. Right. However, this coloration might not be correct because these 3 might be swapped with these 3. Well, we know a 9 cage cannot contain the digits 7, 8, or 9 at all. Let me clear the colors that we had to guess. So using purple for the top 3 digits, we see all of the purple cells must be 7, 8, or 9. The 15 cages are rather unconstrained because a randomly selected digit will average to be 5, and 3 randomly selected digits will average to be 15, so that is the most unconstrained you can have a 3-cell cage be. I can't imagine having a 7, 8, or 9 in a 14 cage is much of an obstruction. I wonder if there's something going on with these columns with the digits from the 9-cell cages that are sticking out. So in a set of 1, 2, 6, well, let's not do colors. 1, 2, 6, 1, 3, 5, and 2, 3, 4. The digits 4, 5, and 6 appear once each, and the digits 1, 2, and 3 appear twice each. So that means these digits have to be 1, 2, and 3 in some order. Which actually feels more useful than the coloring I've given these cages. So let's get rid of that. And let's use cyan for 1, 2, 3. And then running across, vertical in the last column, across in the 5th row. And then if I use yellow for 4, 5, 6, oh, I haven't used this column. Cyan. So that means these cells are all 4, 5, and 6 in some order. This doesn't seem to really solve anything. I mean, consider this cell, it sees 4 cyan cells. That doesn't stop it from being a 1, 2, or 3. Oh, but it can't be. These cells are all different numbers 1, 2, and 3, so therefore none of these can be 1, 2, or 3. And similarly, these are all different 1, 2, 3, so none of these can be 1, 2, 3, therefore this one must be. I'm not sure we can repeat that logic. These cannot be 1, 2, and 3. These cannot be. These cannot be. These cannot be. These cannot be. That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. I think I'll highlight in brown, for I know that they are not 1, 2, and 3. And let's remove a little redundant highlighting. I have to wonder the title, cornered in the 9s. There's no 9s in the corners. Or there's no cages whose sum to 9 that reach the corners. The digits 9 might very well be in the corners. I wonder if similar logic is with 7, 8 available with 7, 8, 9 that we did with 1, 2, 3, but I don't see it. Like, these are distinct, but there's no non-trivial cells that see all 3 of those. These 2 cells equal these 2 cells in some order. Knowing you have a 1, 2, and 3 in a 15 cage, the other 2 have to sum up to at least 12, either 12, 13, or 14. So the lowest any of them can have is a 4. Which does not seem remarkably helpful. I guess that tells me this is not a 1, 2, and 3. Because 1, 2, and 3 plus 1, 2, and 3 adds up to most 5. This would be 10. Therefore this is a 1, 2, and 3. And I guess now we repeat the same logic. This is not 1, 2, well, of course it's not. Oh, well, neither of these is 1, 2, 3. Therefore this one is. The logic does not cascade any further. This highlighting is now redundant. This is equal to this, and therefore this. whatever that's worth. Similarly, this is equal to this and this. Running out of colors at this rate. This can't be soft pink. Or else these two yellow digits would be the same, obviously. This is soft pink. So we're going to be able to color all the cyan cells. At this rate, that feels likely. This can't be 1, 2, 3. One of these is. Not this one. I can't even color this row. These are now redundant. Makes me think we can resolve this. Yes, this can't be 1, 2, and 3. Soft pink. And I guess we need another color for the other 1, 2, and 3. Is there some symmetry argument preventing us from coloring the corner 9s? Well, okay. This 9 doesn't have dark blue cyan, so therefore it's the same as this one. Which must be the same as this one, which has no dark blue cyan. Therefore it has soft pink and hot pink. Which makes this blue, this can't have the hot pink, so it must have soft. I think that's correct. So we have found 7 of them. 2, 3, 4, 5, 6, 8. Very odd. Even. And again 8. Okay, we found all the 1, 2, 3s, and we know which yellows, like these 3 yellows, are the same. It seems that soon we need to break symmetry using the 15s and 14s in some way. Here is a 15 cage that has no digits from 1, 2, and 3, therefore it has 4, 5, and 6 in some order. Is it possible? It is possible to have... No, you can't have 2 purples in the 15 cage. So every 15 cage must have at least 1 yellow. Maybe we should be looking at the 14 cage. These 2 digits sum to 11, 12, or 13. 11 could be 4, 7, 5, 6. 12 could be 4, 8, or 5, 7. And 13 could be 6, 7, 5, 8, or 4, 9. So in each case, it should have one purple and one yellow. I believe. Which makes it not so different from a 15 cage, where these two cells sum to 12, 13, or 14. 14 can be 6, 8, or 5, 9. Again, one purple and one yellow. So if this is a purple, this is a purple, this is a purple, and then these three would be yellows, and vice versa. Doesn't feel helpful. Well, okay. There's one yellow here. There's 3 yellows in the column. Both of these are yellow. That makes this yellow, purple. I dread the possibility of making a mistake at this point. And then this column we have purples, finish the yellows, one yellow, one purple, not sure which yet. This row needs 2 more yellows. This column needs a purple. This row still needs, is this really undetermined? One of each? One purple, one yellow, one purple, one yellow. Odd. So it seems now we have to color them. I mean, let's get started. I was using red, green, blue before. So, and at this point, I think cyan wasn't doing us any good. Okay, red's down here. Then let's just call this one green arbitrarily. And then I guess we'll have yellow, blue is distinct from blue. I guess I have these. Can now be called cyan, right? Green, blue, blue, green, blue. Okay, can we deduce anything? I know these 3 are all different. Obviously none of these yellows sees 2 of the yellows in these center positions. So that doesn't really immediately help. And I'm really tempted to think that the entry point has to be this 15 cage. But I don't see it. Like I know there is a blue here, it's either here or here, there's a green here or here, and there's a red here or here. So maybe this is the entry point. A low, a medium, and a high. 7, 8, 9 certainly does not seem a good place to start. Okay, well let's think. I cannot imagine I have more information available in the 9 cages that I have not used already. I've fully colored all of the 1, 2s, and 3s. It's only a question of which ones are which. Just to make sure I don't lose track, those are the cells that are 1, 2, and 3 that I care about. Well, how many ways are there to make 15? The 15 with a 1 would make these 6 and 8. 15 with a 1 would make this 6 and 8. Is it a problem to have the 1 and this 1 here when this is a 6? No, it could be 1, 3, 5. Conversely, if this is 1, well, that's not an obstacle at all. 1, 6, 8. This would be a 1 and a 6 in the same box. That's fine. The 8 is no obstacle. It does seem we'll get the 7, 8, 9 through these three cages later on. I don't see any relationship between them where these two could be the same or they could be different. It's unknown at this point. This one has to be here or here, but I have nothing constricting that I see which one it can be. Can these be the same as each other? They would both be blue if that's the case. That would be blue. That would be blue. That would be blue. Blue, blue, blue. Blue. Seems fine. Oh, this has to be red, right? Well, that's an important thing to notice. Although the deductions died out faster than I would have liked. This is red, of course. This is green. I have blue here or here. If this is blue, this is red, green. If this is blue, and this is red or green, this is blue. Not knowing which of these are yellow is actually quite frustrating. Surprisingly limiting. Yeah, it's an interesting pattern this makes. Okay, well, have I learned anything? If this is 1, then this is 6, this is 8, this is 6, that makes that 1, 2, that's impossible. If this is 2, this is 1, 3, 5, 2, 5, 8, perfectly possible. If this is 3, this is 1, 2, 6, 3, 6, 6. Impossible, right? If this is a 3, then this has to be 1, 2, 6. The yellow red is a 6. This is a 6. This is a 15 cage that contains a 3 and a 6. 3 and 6 add to 9. The remainder is 6. That sounds impossible to me. So we know cyan is 2. And I discovered that I have I want to remove the auto checking of pencil marks. Excellent, digits, conflict checker, check pencil marks. Thank you. So this is, of course, 1, 3, 5. And I said this must be 8. Now, this is not 1, 3, 5, but I know that because it contains a 2. Right. These are 4 and 6 in some order. This is 1 and 3 in some order. Right. Unconstrained all around. I guess we look at the next one. So if this is 1, 6, 8, could be 1, 5, 9. Did I neglect that? Well, this can't be. This can be 5. Well, if this is 1, this is 1, this is 6. This is 5, this is 9. Okay. If this is 3, this is 3, this is 4. Well, okay, we have a relationship here, right? If this is 1, this is 2, 3, 4, 4, 6. Right, this will just give the same information that this gives, so that's not adding anything. This is 3, this is 6, this is 4, this is 3. These are 5 and 6 in some order. This have to be 5, 3, 5, 7. I really feel like the 14 is the way to go. Knowing that there is no 5 feels like it should be a significant constraint more than this, or this could be a 5, this could be any number, well, any 4, 5, or 6. No, 5 is here. Okay. Suppose this is a 4. And this could be 1, 9 or 3, 7. Suppose this is a 6. This adds up to 8. It would have to be 1, 7. Six, 1, 7, 4, 1, 6, 6, 6, 5. Feels consistent all the way through. Really, once these are solved, really this should be the only puzzle that remains at this point. Imagine that any solution to this will continue to the rest of the puzzle successfully. Which makes me worried that I will need to know the 7, 8s, and 9s. That doesn't sound right. And this, I know it's at 4, 5, 6, so I think there's nothing to add. The only effect of this cage is it's going to help me identify the orientation of these 4 digits. So I think I don't even need this cage right now. All I need is these 2 cages. If this is a 1, this is a 1, this is a 6. These two add up to 14. It's not a 6, 8. It must be a 5, 9. So this would be 1, 5, 9, 1, 6. This would be 3. These two add up to 11 without using a 5. So have to be 4, 7, 6, 7, 8. That feels completely consistent. I don't see how this could later turn into a contradiction. That's assuming this is a 1. If this is a 3, we have 3, 4. This is a 1. This now has to add up to 13 without using a 5. So it's 4, 6, and 7, and 9. Feeling unconstrained here. 3, 2 numbers adding up to 12 could be, and it can't be 4, 8, can't be 3, 9. So this must be 5, 7, 6, 5, again unconstrained. Which makes me think I need to establish a relationship between these two digits, or collections of digits, that is not dependent on these cages, but comes from the pattern in the grid. So then we will retreat from those cages. I did notice that this must be an 8 because of, oops, this relationship here. These two cells, sorry, no, what am I saying? This can't be an 8 is what I'm trying to say. I know one of these is an 8. One of these is an 8. One of these is an 8. And then it goes downhill from there. Well, now hang on. 8. One of these is an 8, so neither of these is an 8. So this is an 8. Maybe that's what I need to know that this is not an 8. Feels unlikely. This is an 8, this is an 8. Right? 8. Knowing this is not an 8 is probably actually helpful. And then I'm left with this ambiguous pattern. But knowing this is not an 8 is probably key. So this is 1, this is 1, this is 6. Well, that's not a 6, 8, that's a 5, 9. Okay. Very good. This is 3, this is 3, this is 4. Again, this can't be 6. This is 5, 7. This is a 5 no matter what. If this is a 6, if this is 6, this is 3, 6, impossible, or 1, 8, impossible. So this is not a 6. This is 4, 5. This is a 4. 3, 4, 8, impossible. 1, 4, 10, impossible. Either way, impossible. So this is a 5. which tells us this is a 5. We probably do not need the red coloring anymore. Blue, blue, green. 5. Last 5 is here. And the last blue is there. It just makes me feel better. Okay, we resume our previous checking. 1, 9, 1, 6, 6, 3. 3 and 6 makes 9, which makes 5. That looks pretty impossible to me. 3, 7, 3, 4. 4, 1, 9. That looks consistent. Okay. Not sure what exactly. Okay. And then, of course, we have these are 3, these are 1, 6, 9, 8, 7, 9, 8, 7, 9, 7, 9, 7, 9, 7, 9, 7, 9, 9. All right. Let us start over with that. Let's hope I have made no error in this component, and that it was just an error in filling this out. 9, 7, and 8. Yes. 15, 14, 15. Okay. 9, 8, 7, 8, 9. 8, 7. 8, 9, 7, 8, 9, 7, 9. Well, that's concerning. Okay. Not the most ignominious end to our puzzle, but let us just boldly switch the 1 and the 3 and see what happens. Okay. As always, the correct thing to do is to stop and think about what you're doing and not just randomly try other solutions. But yes, this is definitely not correct. Okay, let's get rid of all of the yellow coloring, all of that and that. I felt pretty good about the deductions I made that got me the colorings for the 1s, 2, and 3s. And I do not feel good about those. So let us think about this afresh. Okay, this has to be 1 3 5. Where else can I find 5s? One of these is a 5. Right? So that's a 5. So that's an 8, because that is 15. No other 5s are known for sure. I see several possibilities for these digits. This is 1 or 3, making this 6 or 4, consistent with not having a 5. Six, 1, 8. Yes, we had something with the 8s that actually looked like it might be correct. This cannot be 8, this cannot be 8, therefore this is 8. No, no, yes. Eight. So this is not an 8. One of these is an 8. Neither of these is an 8. And we have found 6 of the 8s. The others are here in some order. Okay. And then the rest is 7, 9. Specifically, we should know if these are the same or not. This is the same as this, is the same as this, is the same as this. Okay, so these are opposites. And these are opposites. So if these two add up to 10, 3, 7, or 1, 9, then these two also add up to 10. That makes that 5 and that a 4. I think that's what I had before that failed. If these add up to 12, it's impossible. If these add up to 8, then these add up to 12. Impossible. So these do add up to 10. Four, yes. Four, 6. 4, 6, 5, 6, 4, 4, 6, 5, 4, 6, 4. And then, as before, we have a 5 and a 6. Okay. This must be a 3. Feeling unfortunately familiar. 1, 4, 9, 7, 9, 8, 8, 8, 7, 9, 7, 9, 7, 9, 7, 9, 7, and these are impossible. Everything else is correct. 9, 9, 9, 9, 9, 9, 9, 15, 15, 15, 14. I have to imagine it's some very small translocation in this grid, or in, you know, some combination of these 4 boxes. 5, 1, 2, 3, 4 boxes. But I don't see it. Okay. I can start over. Right. These cells cannot be 1, 2, or 3. Because in each case, I know that these 3 are the distinct digits, 1, 2, and 3 in some order. And these 3 cells see all 3 of them. That makes that 1, 2, or 3. Again, we have some known cells. You can't have 2 1, 2s, and 3s in the same 15 cage. Likewise, already have all of the 1, 2s, and 3s in that column. This sees 3 1 2 3s. This sees 3 1 2 3s. This does not. Maybe this 15 cage is not 3 yellows. Could that have been the error? We have all the 1 2 3s in these boxes. This could be a 1 2 or 3. Oh, forgot one. I know this is a yellow and a purple in some. I know this is a yellow and a purple in some order. That makes both of these yellows. I know this is a yellow and a purple in some order. These are 2 yellows and a cyan. If I recall correctly, at this point I started coloring the 1 2s and 3s individually. I think I'll use the 3 shades of pink available to me. I'm not using purple. I use 1 red, green, and blue, I guess. Or 4, 6, and 7. Okay. these two must be the same. These two must be the same. There must be a hot pink in this column. Just using standard Sudoku rules to deduce which 1, 2, 3s are which colors. And as I recall, the corner is a little tricky. What I learned is that this cage doesn't have any brown in it. Therefore, these two have the same sums. Therefore, these three have the same sums. This also has no brown in it. And we see these can't have any cyan. And this can't have cyan. So this must be 4, 5, and 6. So far, unchanged. Oops. Did I just put 4 purples in a column? Yes. Okay. Hot pinks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Okay. Dust pinks must be here. And then browns. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes. All of those are resolved. And then for some reason I concluded this was a 2. Well, I know this is a yellow and a purple in some order. Yellow and purple in some order. Yellow and purple in some order. Yellow and purple in some order. Yes? Hang on, let's think this carefully. There's 3 purples in here. Yellow. Purple, yellow. Oh yes, I had the box. I can't have 2 yellows and a cyan. That'd be 5, 6, and 3 at the most. That's 14. Well then let's rewind and consider if I did this 14 cage correctly. Okay. From the box I know this is yellow, but they could both be yellow, right? If this were 5, 6, and 3, that would be 14. Something to consider. Yellow and purple in some order. If this is yellow, there's both of these are yellow. Very possible. Yellow, purple in some order. 2 yellows and a purple in some order. Is that a problem if this is purple? This is purple, this is yellow, this is yellow. Right, that's impossible, no? One of these is yellow. Two of these are yellow. It can't be both of these. It can be those. Those can be yellow. That'd leave purple, purple. That feels very possible. I don't see the contradiction I was thinking. Okay, so now we proceed. Why did I think this was a 2? This is a 1, this is a 4. This is a 1. This is a 5 or 6. This is a 1, this is a 5 or 6. Seems fine. It might be at this point I have to track which yellows are the same as which ones. So, don't know if I'm using the same coloring as last time. And as before, one of these must be a red yellow. So this is a 1. This is a 4. I have a 1 and a 4 in the same box. That's impossible. So this is definitely not a 1. Now, previously I claimed a 3 was a contradiction. If this is a 3, this is 3, 1, 2, 6. And then I have a 3 and a 6 in the same box, which is impossible. Therefore, I agree. This must be a 2. And these must be 5s. And this must be a 5, 8 in some order. We have here 1, 3, 1, 3, 1, 3, 1, 3, 4, 6, 4, 6, 4, 5, or 6. Now previously I made some deductions about 8s. I know that one of these is an 8, therefore this is not an 8, therefore one of these is an 8. These wings of 8s means these aren't 8s, which means this is an 8. Also means this is not an 8. This can be 5, 6, 7, or 9. 4, 6, 1, 3. But I already knew this couldn't be an 8, because the only way this could be an 8 is if this were 8, 4, 2, or 8, 6, 0. So, impossible. It still can be 9, 4, 1. It can be 7, 4, 3, 7, 6, 1. It can't be 6, because that'd be 6, 4, 4. It can be 5, 6, 3. Now previously I had decided that this was an 8 and therefore this wasn't. I don't see any possibility of reaching that same conclusion this time without assuming that this is purple. This is a 4, and this is 3, 8. This is an 8. This is an 8. No 8, no 8, no 8. Now these is an 8, therefore this isn't. Right, let's double check that. If this is an 8, then this is. One of these is. This isn't, this isn't, this isn't, this isn't, this is. Oh, is that a contradiction? Okay, let's look at 8s here. Here. Right. One of these is an 8, and this is not. So one of these is an 8. Therefore this can't be an 8. How does that help us? I'd like to trace the colors of the 7s versus the 9s, but I don't have enough 8s in the grid to do that. And green versus blues, which is to say 4 versus 6s, I similarly don't have a good lead on. Wait, I know this is green. Yeah? One of these is green, one of these is green. 1, 2, 3, 4, 5, 6, 7. is green, none of these is green. Okay. I feel like if I say this is not a 5, then I necessarily end up in the same situation that I had last time. What if I assume these two are the same as each other? Then they must equal that. If they're the same as each other, they are 7, 9. So they equal those. So they equal that. And that. And that. And it's impossible. Right? Let us double check. If these two are equal, and they equal that, that and that, 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 and that. Okay, so these two are unequal. This is not a 5, and these add up to 8, 10, or 12. These add up to 8, 10, or 12. In either case, adding up to 12 is impossible, so they both add up to 10, which would make this a 4 and this a 5. And I suspect I am now down the road that previously led me to a contradiction, but not easily led me to a contradiction. Is there some way to see that 5, 4 is impossible? That would make these 5s this would be blue, these would be purple. I don't see the contradiction. Well, maybe there's a problem with this being a 5. Let's find out. if this is a 5, 6, 3, 1, 9, 6. Can this be 1, 9? No. Hang on. This is 5, 6, 3, 1, 1, 7, 7 can't be done. The 1, 9, 5 can be done. Is 6 not possible here? If this is a 6, these add up to 9. These add up to an even number. What am I even thinking? Of course. Of course. Makes that a 5. Purple. This is to be blue. This has to be green, blue, right, purple. Now the 5s and the remaining purples are scattered about here somehow. These add up to 10, which means that if this is not a 5, this adds up to 10 and this is a 4. There's no 8 here. 8. 8. 8. 8. 5. 5. 5. Well, we're out of our contradiction line. And right, so this must be these are 3, these are 1, and then this resolves it. 7, and it is clean up, hopefully more accurately this time. Have I used all of my cages? Yes, I have. So, probably 8s tell me where to go. I think all the 8s are in the grid. 7, 9, 7, 9, 7, 9, 7, 9, 7, 9, 7, 9, 7, 9. Well, that took longer than I was thinking it was going to take, but we got there in the end.